Okay.
In case you didn't know, we're posting.
Alright, so the first thing Brian did was factor his problem, and he made a note. I heard him say it out loud. He said there aren't any holes, right? We don't have any holes.
None.
However, there are two things in the denominator. So he said he has vertical asymptotes at x equals -2 and x equals 2.
Yep.
So in our picture, we're going to go ahead and make sure that we label those. Those are our vertical asymptotes. He also said he had a horizontal asymptote at y equals 1 because when you looked at his original problem, it was 1x squared over 1x squared.
Yes.
So that's his horizontal asymptote. Then he looked at his numerator and said, real tiny here, I have a 0 at -1, 0 and at 1, 0. Would you agree with that from the numerator, that he has zeros there? Then, did you do a y-intercept? Is that what this is?
Yeah.
So his y-intercept was at
It's pretty small.
0, 1/4. Is that right? Is the math right on that? Yeah. Okay, so that looks good. So he said, based on what I have right here, I am going to say that what I've got is a sort of little parabola-like thing in there. Would you agree with that? Based on the points that he's got? Now I need to figure out, though, what the rest of my picture looks like. Because your asymptotes split your picture, in this case, into 3 parts. Left, middle, right. And there's something in every part. The only time you're not going to have something in every part is if you have something like a square root, where you have to restrict the domain because you can't have a negative under the square root. But if it's a rational function or a polynomial function, you're going to have picture all the way across. Okay, so I'd like to know what your gut feeling is on the left side of the picture. We have no points over there. What is your gut feeling over here? Would you say this?
Yeah.
Now, guys, let's talk about our options. Our options are that and this. That's it. Those are the options. Because, remember, as the curve goes off the page, it gets closer to an asymptote. So it's either going to go up or down when it gets to this asymptote.
Oh.
Furthermore, as it goes left, it's going to get closer to 1. Those are the only 2 options. Why is it not this one?
That's not a 0.
That's not a 0. Very good. You cannot cross the x-axis except here. So it's not this. Perfect. All right? Gut feeling. What's happening over there? Same thing on the other side. Beautiful. Now we can describe all the rest of the stuff they want us to describe. What are the limits as x approaches infinity and negative infinity? One, both of them. One from the top. Everybody good with that? What about, I'm not going to write all these out, but what about the limit as x approaches -1 from the left? What's the limit as x approaches -1 from the left?
Positive.
Oh, yeah, -2, I mean. -2. Asymptotes at -2. Approaching -2 from the left would be positive infinity.
What about
I love
-2 from the right would be negative infinity. You did that, we talked about this yesterday, the other day. You have got to focus on that, not the rest of the picture. All that matters is right here, what is happening. All right? All right, one more. We're going to do number 4. And we're about out of time, so we're kind of gonna go through this one together. We're missing 2/3 of the picture, but other than that, yeah.
But he had all the work.
You got all the important stuff in there, yeah. Just the curves.
He would've gotten the work points.
All right.
Is there no VA?
There is no VA. Mr. Gianoli, why is there no vertical asymptote?
Squared up there and we're not using imaginary numbers.
That's right. There is no number that X cannot be. Anything you put in is gonna be okay, right? So there is no vertical asymptote. Is there a horizontal asymptote?
Zero.
Y equals 0. Somebody explain that to me. You are correct.
Bottom power is higher.
Bottom power is
I really
higher.
don't know why.
Bottom power is higher. So when that happens, the limit as x goes to infinity of our function is going to be 0. Now, whether it's coming in from the top or the bottom, I'm going to hold off on that until I get my picture drawn. But would you agree we're going to be approaching 0? Yep.
Yes.
Okay. Do I have any zeros?
Nard.
Oh, I do.
Yeah,
Nard.
throw in 0.
Isn't it right here?
That's
Oh, yeah, a 0.
Isn't that my 0?
Yeah.
And that point is both my x-intercept and my y-intercept. Alright, do I have any holes?
Nard.
Can't.
That's, I thought you were asking for.
Okay. So, in terms of important stuff, it's all here. It's not much, but it's all I got, right? So now I have to figure out what it looks like.
Can you just plug and chug?
Let's just plug and chug. So let's try some points. Let's put in 1. Well, if I put in 1, I get
So it's gonna
Yeah.
start from really high to the left.
How about if I put in 2?
Or, I'm sorry, 2 fifths.
Okay, now we gotta think about this for a second. That's a half, which is 5/10, and this is 2/5, which is 4/10. So isn't this one down a little bit?
It's slowly getting smaller.
Let's try one more. Let's put in 3. 3 gives us 3/10. So are you seeing something like this?
Yes.
So if we plug in -1, the denominator stays the same, the numerator stays the same, only it's negative. So aren't we gonna get exactly the same shape, but negative? In other words, this is an odd function, because if you plug in a negative, you get a negative. Would you agree with that?
Yep.
Cool. Okay,
This was
so
actually.
what am I gonna say over here? The limit as x approaches infinity is 0 from the top,
Yep.
and this one is gonna be 0 from the bottom. So this is our first one, and it's gonna happen to us, I'm sure, again. But this is our first one where going through and doing all the stuff didn't really give us enough to sketch. So we had to do some plotting. You good with that?
Yep.
Okay, all right, let's see. I just gave you a worksheet. I want to look at that, see if there's anything on it that we need to talk about immediately, because I don't want anybody losing any sleep over anything. Oh, wait, no, you have my paper and I have yours, Brian.
Oh.
You just write on my paper.
I did a lot of work
You wrote one page.
Check Brian's work, make sure it matches yours.
Okay.
on it.
Good job.
Alright, I think I'm gonna stop there because, we're already a little bit ahead of you.